Okay, we're in week 5. Again, the hope is that you've paid attention during lecture. You've you've made some attempt to study what was presented in lecture and to go over the problems that we presented to you in lecture. And then now you also have attempted to do supplemental problems. Again, we did combinations and composition of functions, sums, differences, products, and quotients. We did the composition. What's the big deal? Basically, the domain and range is a big deal for a lot of students, but we did go through examples. We also talked about invertibility and inverse functions, concepts of one-to-one, yada, yada, yada. But all that's been presented prior in other lectures. And then we went through some examples. By going through examples, we're trying to hammer down what we presented to you. This is important that you've learned this material so when you move forward, you're more comfortable and competent in what you're doing. So we went through a bunch of examples. There was a lot of work we did. And again, at some point, you should always be saying to yourself, when do I get a chance to try? We want you to try constantly to get the material. And that really is something that you decide to do on your own. But the bottom line is we're expecting that you try the material. At some point, though, you're going to have to, stop watching me and start doing it on your own. That's where the supplemental activities come in. I'm hoping that you've looked at the supplemental activities and that you've done this independently of me on a piece of paper. So right now I'm going to switch to the whiteboard. I'm just going to go through it. Hopefully you're watching along just to compare your work and my work to make sure things look pretty good. All right. So what I'm going to do here is just switch whiteboards. Give me 1 second. Okay, what are you seeing? You're seeing the homework, supplemental activities. I'm going to be doing problem number 1 first. I'll talk about what I'd want you to be able to do if you were presented with this problem on the exam. And certainly what I'm saying by that is that if you saw that, what would you do? Well, I'm going to do the same thing I'm going to do. And for one thing I'd like to write down is I'm just going to write down what they've given me. They give me f of x is a parabola, and the domain of that parabola is going to be, well, looking at it, it says x is greater than or equal to 0. So I'm going to put it down in integral notation, 0 forward. I'm going to put the range down. And to do that, I want to just emphasize, I want to graph this guy out. A real simple graph, by the way. Looks sort of like this over here. And it's a half of a parabola, starts at 0, and it points downward. The parabola opens downward. So what's that going to be? It looks like it, minus infinity, and it goes up to number 1 inclusive. All right. Let's put down g. And what's g? G is a root of 1 minus x. They gave me the domain. And what's the domain over there? Looks like minus infinity. I'm just reading it from the notes, up to and including 1. And the range of this over here, well, I want to point out the range of this guy over here. It's a principal root function. It starts at 1 and it goes off to infinity, something like this over here. So what's the range of that guy over there? Well, 0 hits it and goes off to infinity. Again, domain and range are really important. I want to emphasize here what you're noticing is, this guy's domain is this guy's range, and this guy's range is this guy's domain. And we're expecting that if they're inverses. Now, I'm not claiming they are inverses. I'm just claiming we're expecting that if they are inverses. What we need to show is we need to show 2 things now. We need to show that f of g is equal to x. We'll do that in a moment. And we need to show that g of f of x is equal to x. And we'll do that in a moment. Let's do one at a time. Let's do this one first. What's that going to be? F of g. Well, what's g? The root of 1 minus x. What does f do to that? Well, it squares it, right? It squares it and 1 minus that square. So I'll put that down. 1 minus that thing squared. Well, what's that thing squared? It would just be 1 minus x. And what do you get over there? 1 minus 1 is 9. Minus minus x is x. So this is done. We did a good job there. Let's do this. This is going to be g of f of x. What's f of x? 1 minus x squared. And what does g do? Well, it's a root of 1 minus that thing. So I'll write that down, 1 minus that thing. And what would you get over there? Well, you get the square root of x squared. I got some of a problem over here. I want to tell you what the problem is. The square root of x squared is actually the absolute value of x. And I was expecting to get x back. So let's just talk about it a little bit. And what do you know about g? G is a principal root problem. And so what do you mean principal root? G could only return non-negative numbers. So therefore, this symbol over here is not needed. It's only returning non-negative numbers. So what numbers it return? X in this case. All right. It certainly fits in description over domain and range over here as well. All right. So that's number one. I'm going to go to number 2 now. And let's just, I'm kind of like, say we're going to do this one now. And let me push this on the side. And I'm going to blow this up a little bit so it's easier to read. All right. So let's take a look. And again, as I read through these things, I'm hoping that you've done these prior and things are not going too quickly for you. This is number 2. It says given f of x. I'm going to write a little bit differently. F of x is, just give me 1 second here. F of x is equal to, well, I'm going to just simplify. It's really 1/2 of an x minus 3/4. The domain of this, it's a line, is all real numbers. And the range of this is also real numbers. Just a very simple line. Let's put down g of x. And what's g of x? Well, it's going to be 2/3 of an x plus 1/3. Again, it's another simple line, domain being all the real numbers and the range being all the real numbers. Now, what's their question? Their question is, find the composition f of g of x. Let's write this down. F, this is A, of g of x. Well, it's going to be f of, well, what's g? It's 2/3 x plus 1/3. What does f do to that? Well, it's 1/2 of that. We'll check it with the key later. Right? And again, I know it's confusing, a lot of writing, and since I don't know what you're talking about, we're looking at the notes at this point. So 1/2 of, whoops, made a mistake, and put the x over there. 1/2 of that, we're looking at what f does to that, minus 3/4. And what does this give me? Well, if I look at that, just multiplying it out, what would you get? 1/3 of an x plus 1/6 minus 3/4. If we can do some arithmetic, I'm going to say it's a good idea to do that. And what would you go over here? I'd say, I guess you did 6 and 4 would be 12, right? And that's going to be 2 minus, again, I'm just getting coming out of 12. 2 times 6 is 12. 2 times 1 is 2. What times 4 is 12? 3. And 3 times 3 is 9. All right, so I'm going to keep writing it. What do you get? 1/3 x. Let's see, that would be minus 7/12. All right, I'm going to write down the domain and range. Fairly simple. This guy's domain is all real numbers. What does he try to fork over to f? All real numbers. Can f handle that? Yes. So what's the domain of this guy over here? All real numbers. Whoops, I crossed it out. Domain. Again, we'll check the key later. All right, I'm going to do the next one. And what's the next one going to be? Whoops, sorry about that. It's going to be B. And what's B? B is g of f. What's f? 1/2 x minus 3/4. And what does g do to it? 2/3 times it. And then it adds a third to it. Let's put this down. So 2/3 times 1/2 would be 1/3 x. And let's see, 2/3 times minus 3/4 would be minus, well, 3's cancel, 2 goes into 2, 2, 1, 1/2, not bad, plus 1/3. Let's keep going. It's going to be 1/3 x minus, let's see, I guess a 1/6, right? That would be what? 3/6 plus 2/6, which can be 1/3 x minus 1/6. All right. Again, what's coming in are real numbers. What's g going to return? Well, what's f going to return? All real numbers. Can g handle it? Of course it can. So what's the domain over here? The same deal. All real numbers. Fairly simple. All right. Again, the answers are on the page. I'm just going to go to the next page over there, And I want to see if I got the right answer. What was that? I don't look answered. I think I'm always right. I never think I'm right. Oops, made a mistake. Give me 1 second. So I notice they put a different answer down. I'm just gonna put down what they put down. Look like they got a 12 here, right? So it'd be 4x minus 7. And that's the answer they have. And I'm clearly seeing that here and here. All right, let's go to the next one. I notice they didn't put this answer down either. And they put a 6 down. And that would be 2x minus 1. That's the answer they've written down. Yeah, pretty good. And they put the domain down as well. All right, let's go to the next one, which is going to be, I guess, problem number 3, right? Let me go to that. And let's put problem number 3 down. All right. And I select it over here, push it to the side, and I get this over here. And I'll put this down now. All right. Okay. It says determine graphically whether the function f of x is 1-to-1. All right. So they did say graphically. So let's just make sure you understand what that means. We need to graph out. Sorry about that. We need to graph out f of x. Well, I'm going to say, looking at it, I'm going to do a real primitive graph over here. Looking at it, I'm going to say it starts at 4. And at 4 would be 0. And then it has to be bigger than 4. And it's a root function. And what does that look like? Like this over here. All right, always going up. So what do I need to do? Determine graphically if the function is 1-to-1. Well, all I got to do is, visualize a horizontal line. And I'm hoping you can agree that if you drew a horizontal line, it would only hit this graph at most once. All right, and that's good news. Let me write this down for you. The domain of it is going to be from 4 to infinity. And the range of this thing is going to be from 0 to infinity. What do I know about this function? It is 1-to-1. It clearly passes the horizontal line test. Let me show you that over here. The graph clearly passed the horizontal line test. Therefore, the function is a 1-to-1 function. All right, this is a 1-to-1 function. All right, let's go to number 4. Now, let's take that down for you. And put it on the side. Whoops. And blow it up a little bit. And let's take a look. Find the inverse function algebraically. Well, it shouldn't be that difficult. Let's write this down. So what do you got? F of x. I did it again, didn't I? So f of x equals the root of 9 minus x squared. And they tell me that the domain of this problem, the x's in the problem, are between -3 and 0. All right, so what I want to do is just briefly discuss how to graph that guy. And if I were graphing that guy, put on the side a little bit, I'd put down y equals, and so why do you need to graph it for the range for the most part? You might get better at this over time, but right now, I'm not going to say it's a speed contest. You need to start thinking. So I'd square both sides. Y squared is equal to 9 minus x squared. And then I would add x squared to both sides. And what do you get? You actually get an equation of a circle. And I'll put that down for you. It's a circle centered at the origin. I had a rough picture. We'll talk about more detail later. But there's a problem here. It's not a circle. And I'll tell you why it's not a circle. If you look at this over here, y, it has to be a positive number. I should say a non-negative number because it's a principal root problem. So this graph's not correct. I'm going to erase it. All right, over here and erase this over here. All right, I'm going to erase that whole thing. And put that down for you. It looks like over here. Looks like this instead. All right, that's what the y is. Positive number greater than or equal to 0. I got another problem. They tell me the x only is between -3 and 0. I got another erasure to make. All right, I erase this business over here. And I put my real graph down. I'm going to put this graph over here. And it's going to look like this now. And this is -3 on the x-axis, and that's 3 on the y-axis over there. So what do I know about this thing? It definitely passes the that horizontal line test. I'm going to write the range down for you, though. And what's the range going to be? 0 to 3. Okay, I want to write down the inverse of it. That's our notation for it. That -1 is read as F inverse. It's not a reciprocal. I don't know what it is yet, but I do know one thing. I do know its domain. And what's its domain going to be? 0 to 3. And I do know its range. And what's its range? -3 to 0. If I were to draw a picture of that, what's that going to look like? Well, let's put that down for you. It's really not that bad to put down. Let's rotate it. Looks like this over here, where this would be 3, and this is -3 over here. Again, looking at it, domain clear 0 to 3, and the range of it is from -3 up to 0. You know what? I didn't, my penmanship's probably pretty bad there. Let me get the eraser out, make sure I have to correct it. Okay. All right. I got to get that F inverse now. Let's go through it. And remember what we're going to do. We're going to change the F of X to Y. We're going to interchange the roles of X and Y. I'm going to square both sides and solve for Y. And what do you get? 9 minus X squared. I got troubles now. I'll tell you what the trouble is. Y is equal to plus or minus the square root of 9 minus X squared. It can't be both. It cannot be both. Look at the picture though. What do I mean by that? Look over here. What does the Y have to be? Negative, if you look at that. So let's write that down. Then we'll look at the answer key. Minus 9 minus X squared. I'm going to put a circle on that, around that. And I'm going to look at their answer. All right. So what they say? Find the inverse function of F algebraically. We did that. And when I say use a graphic utility, well, I use my brain to do it, to graph both F and F inverse. Maybe I should write that down for you. This is F. This is F inverse. And what's F inverse in the box over there? Let's see if we got the right answers though. And I'm seeing it. F inverse of X is equal to minus the square root of 9 minus X squared. Did a good job there. And I put the domain down to 0 and 3. All right. Let's go to the next question. And again, I realize for a lot of students, if you have not studied yet, this seems like it's going really fast. You have to study in order to do this material. All right, this one, a little more difficult. And I want to tell you it's a little more difficult. The graphing, it might be really difficult for a lot of students. I don't mind using technology, but the bottom line is technology is useful, but it's something you shouldn't lean on too much. All right, but this kind of problem, I guess, using technology might be a good idea. All right, let me see if I can do number 5. Let me get rid of this guy over here. All right, I'll read it to you. It's finding inverse function F algebraically. Before I do that, I know it's difficult. I'm not saying it's an easy problem over here, but I do want to get the domain of it. I think I should probably write that down. And the domain of this guy over here is looking at it. I know the bottom, that is a root problem. So I know X minus 1 must be greater than or equal to 0, but it can't be equal to 0 because then you'd have a division of 0. So I'm going to put this over here. So the domain really is not that bad. It's greater than 1. All right. So what does that mean? It means it starts at 1 and it goes off to infinity. I got to be honest with you. The range for a lot of people can be incredibly difficult to do. All right. Incredibly difficult to do. But, kind of looking at it, I hope you realize what I mean by looking at it. You have 1 divided by some number. This number in bottom is always positive. So I hope you realize whatever this thing is, it could never be a negative number. Never. Can't be a negative number. But, the bottom line is, what could it be? Certainly this number could get very close to 0, which means that this 1 divided by a very small positive number would blow up to infinity. The other one I want to point out is that, I'm sorry, maybe I misspoke there. Again, if I got really close to 0 here, right, that this would blow up to a very large positive number. All right. The other thing I want to point out is that this thing becomes an incredibly big number. This bottom becomes 0 really quickly. So I'm going to say, just thinking through it, I'm going to say it goes from 0 to infinity. All right, let me just repeat what I was talking about before. I'm thinking if we get close to 0 here, this thing becomes an incredibly small positive number, and 1 divided by an incredibly small positive number just blows up without bound. The other thing I'm thinking about, if x gets really large, a large number minus 1 is an incredibly large number, and the root of a large number is, of course, a large number, and 1 divided by incredibly large numbers is going to shrink towards 0 very quickly. So someone says, why do you spend so much time doing that? It allows me to write down f inverse, maybe not knowing what it is, but what I do know its domain and range. What's the domain? Well, it's the range of f, which is 0 to infinity. And what's the range of it? Well, it's the domain of f, which is 1 to infinity. All right. So bottom line is I'm just going to go through that algebra now with you. All right. Might be difficult. Well, let's write this down. So what do you get? Y equals, I'm replacing f with y, 1 over the root, x minus 1. What's the next step? Interchange x and y. What's my next step? I guess try to solve for y, right? So I'll go over here. That would be root y minus 1 equals, let's see, 1 over x, right? Square both sides, and you get 1 over x squared, and then add 1 to both sides. Not so bad. I'm sorry, x squared. All right, just a little bit differently, x squared and 1 plus x squared. All right, so I'm going to say I know this guy over here is 1 plus x squared over x squared. And I'll put a circle around that. All right. It also says use the graphing utility. I will go to a graphing utility later, but right now I just want to continue to work through the work, and I'll just point out there's also hopefully a picture in the notes somewhere, but we'll take a look. We'll go to the next page in a second. Let's see if I got it right though. And I'm looking at f inverse. I'm seeing that. I'm seeing this. And I'm seeing the domain down. And that's good news. I'm seeing all that information over there. All right, let's go to the next one. Let me just shrink this down a little bit. I notice a lot of work for students, and we're going to try to encourage that work from you. All right, let's go to the next slide. And let's take a look at number 6. And I'll put a little, pull it to the side here. Let's blow it up. Given f of x equals x cubed. And then you got, g of x equals 2x minus 1. Well, it looks very familiar problem, isn't it? And before I do anything, I certainly would like to communicate to you that we need to know domain and ranges this over here. So let's write this over here. And I'm going to write down f of x. Oh, I did that again, didn't I? F of x. And that's going to be x cubed, right? Its domain is all real numbers. And its range, its cubic function, is all real numbers. Again, it's a cubic function, paracubic function. What does that look like? Sort of like this guy over here. All right, a real sloppy picture of it. And let's do g of x, right? Not so bad. G of x was that. That's 2x minus 1. And, domain of it's a line, all real numbers. And what's the range of it? All real numbers. So everyone's allowed in and everyone's being pumped out. And both functions, by the way. Let's write this down. Let's write a down first. And what's a? F of g of x. It should be easy to do. And what's g of x? Again, it's not a memorization skill, it's a reading skill. It's going to be g of x is 2x minus 1. Now, what does f do to it? It cubes it. There's going to be 2x minus 1 cubed. All right, let's go through the domain and range of it. Looking at it, the domain coming in is minus infinity to infinity. What does g try to give back to it? Minus infinity to infinity. Can f take it? Of course it can. So what's the domain of this guy over here? Minus infinity to infinity. Look at that here, and you're seeing that. Let's do the next one, b. What's b? G of f of x. Let's see, g of f of x. And then the big question is, what's f? Well, not a memorization, because you read it, it's x cubed. What does g do to that? It doubles it and then subtracts 1 from it. And again, just thinking about it, who's coming in? All the real numbers. What does f try to give g? All the real numbers. Can g accept it? Yeah, he has no problems with it. So this is going to be the function, and its domain is going to be minus infinity to infinity. Everyone's coming in. It's a good problem, easy problem. Let's take a look at it, and we did a good job. All right, keep going. I'm going to go back, and that was number 6. We are now going to do number 7. And number 7, for a lot of students, they might say, what are you trying to do to me? Why you're making my life difficult? It's not a difficult question. All right. So someone says, what are you going to do over here? It would be nice if I could read it. And my reading, I'm going to look at it, and I'm going to put down its G inverse of F inverse evaluated at -4. Right? There's many ways to do the problem. Don't feel like there's only one way to do the problem. But I got to find out F inverse of -4. Right? Now I claim that's going to be easy to do. And let me put out what I mean by that. If I know F of X is equal to X over 8 minus 4, you can make a table of values up here that would be X and F of X. But what I want to do is I want them to be rotated, and I want to get the -4 over here. All right. So how would you do that? What number would give you my X would be 0, right? This would have to be 0, right? Fx has to be 0, right? All right. I made a mistake. I just realized it. And again, it's probably bad thinking. Let me just erase this for a second. I wasn't thinking right. And I'm sorry about that. I'm not sure why I thought that. I don't want to do that. That's what I'm going to claim. But what I want to do is this. And this is my part of my bad thinking over here. X F inverse. All right, I know it's tough. I'm sorry I made a mistake there. But really what I want to do, this is -4, right? So let me go back over here and put this one down. And that's going to be a rotation of the coordinates. All right, what do I want over here? I don't want the X column in the Y column. Now, what value of X would do that for me? Would have to be 0. All right, let's go back up here now. G inverse. What's F inverse of -4? It's just 0. Okay, now let's see if we can do the next guy, which is going to be the G problem, right? Let's put this down. And I'm going to just maybe push this on the side a little bit. All right, let's go over here. And I'll put down what I'm given over here. I'm going to put X and G of X. I know what G of X is, by the way. And over here, put that inverse function down, which is going to be X G inverse of X. All right. So someone said, what are you going to do over here? I want to evaluate the G inverse at 0. Now, what does that mean over here? That means the G of X would be 0. Just rotating the coordinates. And I want to figure out what the X is going to be because I'm just rotating coordinates. And I know what G is. G is over here. And if G of X equals 0, what do I have? I have 0 equals X cubed minus 8. Well, if you add 8 to both sides, that's not bad to do. You get 8 equals X cubed. Well, now I know X is going to be the number 2. So this will be 2 over here. So what's this going to be over here? The number 2. All right. Got this right over here. However, a lot of students looking at it and say, I don't think I could follow anything you said there. I'm going to say that you could do it differently if you want, and you could do it by finding inverses. So for example, if you want to write down F of X is equal to X over 8 minus 4, let me just put this down for you. Y equals X over 8 minus 4. Change X and Y around. That's X equals Y over 8 minus 4. Add 4 to both sides. Y over 8. Multiply both sides by 8. You get 8x plus 32 is equal to Y. So I can write down F inverse. That's 8x plus 32. Let me put down G of X down. And what's G of X? X cubed minus 8. It's another way to do the problem. You say it's too much work. I think you got to do the work you want to do. I'll write this over here. Y equals X cubed minus 8. Change X and Y's around. Y cubed minus 8. X plus 8 equals Y cubed. Or Y would equal the cube root of X plus 8. And this would be G inverse. All right, let's go back to the original question. What's the original question going to be? let's see, G inverse of F inverse of the number minus 4. Let's see if we can do that. F inverse of minus 4. Well, that'll be 8 times minus 4, which is minus 32, plus 32, which is 0. I'll write that down for you. So it's going to be G inverse of 0. And now I got to look at G. What's G inverse of 0? It would just be the cube root of 8. What's cube root of 8? 2. We're getting the same thing every single time. So again, you want to think through it, that's fine. If you want to do some thug work and get the results of what the inverses are and do it that way, that's fine as well. All right, we're going to do number 8 now, a little more complicated. And I'm going to, again, when I say complicated, a lot of people are going to say, I can't do that. You can try. All right. And we want you to try. And so it says, why do you want to try? We want you to move forward and become successful. That's our whole goal. All right. Verify graphically that each of the following functions is one-to-one. Well, I got to be honest with you, it should be easy to do almost under all circumstances. All right. So let's look at A first. And looking at A, I hope you realize that, basically we're looking at a very simple graph of this one. And I'll put down, this is A. All right. So what would you get there? If X is 0, right, you get 3. And that's a point there. It's a line though, right? And so the next one I put down, I guess I put down maybe 1 for X. I get minus 2, right? And then I draw my line. All right, that one's done. Now, what do I mean by that is if you drew a horizontal line, it passed the horizontal line test. So I'm going to say that's really simple to do that particular problem. And you want to make sure you know that A was a simple problem. Now, of course, someone says, what are you going to do now? Well, I certainly would like to do the next one. All right. And so what the next one's going to be? I got to graph it, right? Well, next one looks tough. I'm going to skip that for a second. I'm going to go to C. And I know C, it's a little familiar to me. And it says, what do you mean it's familiar? I think I've done these before. Whoops. And remember, we did a problem like this before. It was 9 minus x squared. It was a circle, but this is just going to be a semicircle. And then they say x is just between 0 and 4. So I would get a problem that looked like this over here, where this would be the number 4, and that would be the number 4. What do I know about this one over here? Also passes that horizontal line test. So C and A were really simple to do. All right, let's do A. Again, I'm kind of just marching through simple ones. And I know this is a parabola, right? X squared minus 1 parabola that opens upward, has a vertex at minus 1 over here. And it definitely opens upwards. And this is the number minus 1 there. But here's the deal. They say X is only going to be negative numbers up to 0. So it looks like this over here. So I'm also going to claim this one here, also super simple to do. That horizontal line test again. All right. All right, the other ones might be a little more difficult, but kind of warming up to this. I want to see if I can do it. And I want to see if I can do D now. I want to see if I can do D. I'll look at it. Again, we're just doing a rough picture. I'm not saying it's a great picture. X and Y axis. And I'm going to say, well, they goes from 2 to infinity, right? So I know it's starting at 2. And what would the value be at 2? It would be 5. It's really a standard translation problem. Standard translation, all right? So at 2, it would be equal to 5. And then what does it look like? It looks like a root function. Looks like this over here, all right? That's curvy, by the way. What do I know about this thing? Passes that horizontal line test again. All right, I'm going to say we did good with that. And now I'm going to look at B. All right, more difficult, no doubt about it. All right, so let's put this one down. And again, just do a real rough picture. I don't mind using technology. And minus 1/3 trouble. I know this is difficult. I'll put this down for you. All right, that's x equals minus 1/3. it's got a, and again, we'll certainly spend more time in graphing rationals, but right now I'm hoping you can do some technology. And you got another, so these are asymptotes. This is y equals 1/3. And let's take a look at this. I'm going to say sort of looks like this over here. Whoops. Give me 1 second. I made a mistake here. I don't know what happened. Whoops. Give me 1 second here. I'm going to draw my line in over here. Something like this over here. I know it's tough. Again, you can use technology if you want. Maybe something like this over here. All right. So the question is, does it pass that horizontal line test? Well, not where you draw one, it's going to hit it at most once. All right. Okay. That's not so bad. Let's go to the next one up. And I'm going to just shrink this down a little bit. I think we're done with that page. And now we can go to the next one. And I guess we just did 8, right? Yeah, we're going to do number 9 now. All right. And then we'll do 10. All right, fairly simple. I want to point out what I mean by fairly simple. I'm going to write these things down for you. This is a sum, a difference, a product, and a quotient. So let me go through it separately. F of x, oops. F of x, I keep doing that, don't I? F of x, its domain is going to be minus infinity up to 1. Its range, although not important, we want to start learning this right now, is going to be from 0 to infinity. Let's put down, that's F, let's put down G now. Again, if you're struggling here, I would encourage you to come by during office hours. But a lot of times the struggles here are basically you haven't done the homework from prior sections, and then you wonder how these things can be got so quickly. I don't solve an inequality at this point. And so I'm going to put down G's domain. Again, we're talking about G now. And this guy's domain is going to be, let's see, x squared minus 4. And let's see, x squared minus 4 parabola opens upward. So I'm going to say minus infinity up to minus 2 union 2 to infinity. All right. Again, if you're struggling with that, you're really struggling in a different section. I didn't do work, and maybe I should do work for that, but I think you guys are okay. All right, so let's put this down. You know, what's f of f plus g? Just add them together. That's super simple to do, right? Just add them together. The problem for a lot of students is they wonder, what's the domain of that? It's the intersections of the sets. So I'm going to put down f's domain picture, visual, and f's domain is going to be from, minus infinity up to 1. This is 1. And it gets shaded in like this. And G's domain, right? Well, it's going to be, minus 2 off to minus infinity, and then 2 to infinity. That's 2. Where do they intersect? Well, if you look at it, they're only intersecting in not a small region, but a region minus 2 and below. And that's why this is written over here. All right, G minus F, all you got to do is put that down. G minus F, fairly simple to do. Same intersections of the sets. G times F, very simple to do. It's the product of those two things, intersections of the sets. This is more complicated. What is it going to be? F divided by G. F divided by G, just write it down. There's no need to do work on that. Question is, why does this thing look different than the other ones? It's still the intersection set, provided the bottom is not equal to 0. Well, unfortunately, minus 2 makes the bottom 0, so it must be excluded. Now, relatively simple, but you want to think about that. You really do want to think about that. All right, let's go back to the other question, which is going to be number 10. Number 10 is a little more challenging. Whoops. Undo is good because I can just undo something. All right. All right. Let's get rid of this thing over here. And let's do one at a time. All right, I'm going to do A. And, you know, domain and range, I'll put this over here for A. Its domain is minus infinity to infinity. And its range is also minus infinity to infinity. This actually makes it a lot easier for me. What do? Change f of x to y. Interchange x and y. We'll look at the key later. That's going to be 3 minus 5y. Solve for y. Yeah, you need to know basic algebra. You get 3 minus x over 5. And the domain and the range, pretty simple. Just a rotation, right? And they're both the same. How could you get that wrong? Right? This is f inverse. I'm sorry, I should write f inverse down. And again, domain and range, minus infinity to infinity. I certainly want to encourage you to look at the answer key. And by that, I mean, you be critical. If you didn't get it right, say I didn't get it right, do it again. Do it until you get it. All right? Or unless you really think I've made a mistake, and then confront me over it. Say, yeah, I think you made a mistake. All right, I can go to B now. All right, A is done. I looked at the answer key. I felt pretty comfortable about that. And I'm going to go to B now. All right, B is a little more complicated. And let's take a look. All right, so let's put B down. Whoops. Well, I'm going to write F down. And F's domain, right? And what's that going to be? Minus infinity up to minus 1/3 union minus 1/3 to infinity. I got to be honest with you, the range for a lot of students is really, really difficult. I would say we did graph this out before, but I'm not going to say you're convinced of it. You may want to start using a calculator to get better pictures, but at some point, it should be kind of obvious what the domain of it is and what the range of it is. But I'll put this down for you. All right. And I'm going to go through the work now. What's the work going to be? I'm going to change f of x, we're on B now, to y. I'm going to interchange the roles of x and y. Oh boy, this sounds like work, isn't it? I'm going to multiply both sides with the LCD. You would get 3xy plus x equals y minus 5. Just really basic algebra for the most part. I'm going to get the y's on one side because I'm going to try to solve for y, right? And you would get minus x minus 5. Factor y out. You get 3x minus 1 plus minus x minus 5. I would divide both sides by 3x minus 1. I don't like the way that looks. I'm going to multiply top and bottom by minus 1. What are you going to get? X plus 5 over 1 minus 3x. What's the domain of this guy over here? I'll put the domain and the range down for you. Well, I got this from the prior work I just did. So minus infinity to 1/3 union 1/3 to infinity. We'll look at the key later. Minus infinity to minus 1/3 union. Whoops. That's sloppy. Let me get my eraser out. And then 1/3. I notice I copied something wrong on the top. Let me get my eraser out. No, I'm sorry, I didn't copy wrong. I copied wrong in the bottom. Okay, let's look at the key, see how we did. And I'm looking at it now. Yep, got it good. Let's keep going. And let's do C now. All right, so I'm gonna pull over side and we'll put C down for you. And what's C? C is f of x equals the square root. They're very familiar problems, aren't they? And the x is between 0 and 4. I shouldn't write. I was going to write the domain down. And I'll put the range down. The range for this thing is going to go from, let's see, domain goes from 0 to 4. This is semicircle, positive numbers. It's also going to go from 0 to 4. All right, let's see if we can do it. And change the f of x to y. Interchange x and y. Solve for y. What do you get? X squared equals 16 minus y squared. Let's see, y squared equals 16 minus x squared. And y, oh, here's the trouble, plus or minus 16 minus x squared. All right, it can't be both, by the way. So what are you doing? You're looking at the original problem. It's returning positive numbers. So what do you got over here? Y equals the positive. What's the domain of this guy over here? 0 to 4. What's the range of this guy over here? 0 to 4. Look at the key. I can't emphasize that enough. And we're seeing that. I'm not putting the ranges down for us, though. All right, let's go to D. All right, I'm going to push this up. You have to remember what D is. I think I can. A lot of work, though, isn't it? What's D? Well, D is f of x. Again, I'm coming from memory, hoping I make a mistake. We'll look at the key later. F of x equals 5 minus, and this is really a deja vu problem. We just did this before. Not the whole thing, but part of it. And the domain of this thing over here, 2 to infinity. And the range of this thing over here was, let's see, minus infinity up to the number 5. And we did that prior. All right, let's keep going. And get a little better at this. So I'm going to say y equals 5 minus the root of x minus 2. Well, let's keep going. What do you get? Y plus 5 equals minus the root of x minus 2. I'm going to square both sides. You would get, whoops, I want to be consistent, and I'm not being consistent, and that's not good, especially at this level of the game. Although this can be done, not a good idea. I'm going to interchange x and y. Now, I apologize. I was going to do that later, but I should always do that in the same order every single time. What I'm going to do now is, solve for y. I'm going to get x minus 5 equals minus y minus 2. Square both sides, you get x squared minus 10x plus 25. If you square the other side, you just get y minus 2. I'm going to add 2 to both sides. When you get x squared minus 10x plus 27 is equal to y. So I found my inverse. I'll write this down for you. And it's going to be x squared minus 10x plus 27. The domain is minus infinity up to 5, and the range of it is 2 to infinity. We'll circle on that. Look at your answer key. The reason I asked you to look at the answer key is we want to make sure that you've got the same answer we have, right? Now, of course, if you don't have the same answer, someone's got to be wrong, right? So let's take a look at it. Did a good job, all right? Let's go to the last one, which was letter E. I'll put this down for you. Again, if you need to, go back, like what I'm doing over here, and look at what E is. There's nothing wrong with that. What I'm going to do is going to write down. This is what you should do in your notebooks anyway, writing things down and just going through the problem. What's f of x? F of x is x squared minus 1. And what do I get over here? I get the domain that's given to me between minus infinity and up to 0 inclusive. What does this thing look like? A parabola. So make sure it's pretty easy to grab. We've done this before, by the way, many, many times. So I want to put the range down for you. And the parabola looks like, let's take a look. It would be, the vertex would be at minus 1, right? And then it opens upwards, of course, but we have to be negative, so it's over here, right? So I'm going to put down the range of this guy over here. And what's the range of this guy over here? Well, it looks like it's starting at minus 1 and going off to infinity. So I can write f inverse down pretty quickly. Maybe not the function, but the domain and range of it. What's the domain of that guy going to be? Minus 1 to infinity. What's the range of this guy over here going to be? Minus infinity up to 0. All right, let's see if we can get the work done. What do? F of x becomes y. Interchange the roles of x and y. let's see, I guess add 1 to both sides, x plus 1 equals y squared, and I'm back trouble again. What's y? Plus or minus the root of x plus 1. Okay, what does it have to be? Well, again, I want to point out to you, you're really looking at this guy over here, and what does it have to be? It has to be returning negative numbers. All right, it does return 0 at one point, but negative numbers. So which one is going to be? Going to be the minus. Put this over here. Minus the root x plus 1. And put a circle around this over here. And we're going to look at the key. And again, someone says, why do you look at the key? Verify that we got it right. And you got it right. All right. Let's do number 11, the last problem. On the whiteboard for you. Whoops. I got to get that paper out for you. I'm sorry. And number 11. All right, let's take a look at number 11. Given f and g, find the following. Oh, it's one of those problems again, those composition problems. And what I'd like to do is write down the preliminary work was something I need to know, f of x. Again, if you're struggling, the reason that the lesson struggles is that they have not done enough study in prior sections to understand what's happening over here. But the domain of this guy over here and the range of this guy over here, well, the range is going to be positive numbers. So it's going to start at 0 and go off to infinity. All right, include 0. The range of it is going to be, well, looking at it, certainly 5's in it because 5 would give you a 0, and then everything below 5. So minus infinity up to 5. All right, let's do g now. And what's g? It's x squared plus 4x. All right, let's talk about the domain. Fairly simple to do. It's all real number. Let's talk about its range. The way I'm going to do that, I'm going to just briefly talk about pictures. And I know this is a parabola. It's got an x-intercept at 0, or y-intercept at 0 as well. Let's see where else. I guess you put 4x squared plus 4x. I guess that would be minus 4, right? It's over here. And I know I got an axis symmetry at minus 2. I know the vertex would be there. I'll write this over here. Fairly simple. So you do math 100. Oh, minus 2 would give you 4 minus 8 minus 4. Probably looks sort of like this over here. That'd be great. So what's the range this guy over here? Well, it looks like minus 4. It touches it, and then it goes off to infinity. All right? All right, let's go through the work. And someone said, I don't know what the work is. It's the questions. And the first question is A. What's A? F of g of x. We'll go through it in stages. F, what's g? X squared plus 4x. And what does f do to it? It takes the root of it. It's the tough part. It's 5 minus the argument, minus x squared minus 4x. All right, here comes the real tough part for students, the domain and range of it. Now here comes the problem. Who does let f allow in? You have to look at it. He allows minus infinity up to 5 in. I'm sorry, this is G. Maybe I'm sleeping or something. But I'm glad at least I think about what I'm doing, that I get confused and I say, I must have made a mistake somewhere. We'll look at the key later. Who is this guy? This is G. Who does G let in? G lets in minus infinity up to infinity. All right. And who does he pump back out? He pumps back out minus 4 to infinity. All right, here comes the problem. What can R accept? Right, what can R accept? I'm sorry, that's the range. I'm sorry, I didn't mean to say that. What does F accept? minus infinity up to 5. All right, so minus infinity up to 5. And it's the tough thing. I mean, for a lot of students, they're looking at it and saying, well, I don't know how I could ever possibly achieve that by thought alone. But let's go through it again. So, G lets in everybody, but G returns minus 4 to infinity. That's what it returns. But here's my problem. I can't let that happen because the domain on F has to be minus infinity up to 5. So what I'm going to do over here is I'm going to say that x squared plus 4x must be less than 5. You know what it says over here? It must be less than 5. Let me write that down, or equal to it. Have I seen those before? Of course I have. This is the past. And when you get there, x and x, boy, it's going to be really nice if it works out. 5 and 1, plus minus. Put a little number line down. I know it's tough. Let's see, minus 5 and 1. And let's take a look at this. I guess I shade these in, right, because they could both be zeros, right? Let's go between minus 5 and 1. And again, hopefully by practice alone, you're good at this. Let's see, like 0, what would I get? Yeah, that would work out beautifully. A negative number. And if you go after 1, like took 2, nope, that's not working. Took out minus 6, nope, that's not working. So now I got it. What's the domain of this guy over here? Minus 5 to 1. Let me circle it. Again, I can't tell you enough times. Please look at the answer key to verify that what we're saying is correct. All right, so where they have 5 minus x squared minus 4x, a little different order, by the way, minus 5 to 1. Let's do the next one, which is b. And what's b? B is g of f of x. I'll write this down for you. What's f of x? The root of 5 minus x. What does g do to the argument? It squares it. Well, if you square that argument, you would get 5 minus x plus 4 times the argument, which is 5 minus x. Let's take a look at it. And who's coming in? We're talking about f now, right? F allows in minus infinity up to 5. And what does he give back? He gives back 0 to infinity. Can G accept that? Well, what's nice about G? G can accept anyone. So this is certainly fair territory. So who's coming in again? Minus infinity up to 5. And this is the answer. So let's look at the answer key. See if we got that. 5 minus x plus 4, root 5 minus x minus infinity up to 5. All right, so I'm going to say we're done with the whiteboard. And I want to just briefly go back to talking about SAGE. All right, so let me do another screen share with you. So we're at the related SAGE code section. All right, related SAGE code section. All right. I want to click on this over here. A web browser will open if your computers are properly configured. You will be able to launch what's called CoCalc, which is an online version of SAGE. No need to install software. All right. And again, I'm going to start a project. Let's give it a second. Let me do a new project, a SAGE worksheet. And again, what I want to encourage you to do is, looking at this thing, just type in what you're seeing. Remember, shift return. X and Y are variables. I'm going to do different software today as well. All right. Do not feel obligated to use software that I tell you to use. You should find products that work for you. All right. And then what I do, a little tired, I'm going to just copy this in. So that's a lot of code copying, right? You're going to be surprised by this, but a lot of code is just code copy. People copy it. Whoa, made a mistake. Let's see what happens over here. Implicit plot, square root, x cubed plus 1, color red. Let me see what this says. Execute. Let me back over. I'm not sure what the copy paste is always a problem. Let me get rid of color. There it was. Something to do with red. Let me just do that again. Color. And there's a point to this. A lot of times when you copy paste from the internet, you're copying characters that have been translated into different code. And I want to tell you what was translated to different code. The red with the quotes on it was translated. I want to point out the difference between the ones I typed in and the ones that are being copied over here. These are actually quotation marks over here. These are just simply little hash marks. Let's do the next one. And, certainly I'm going to talk about this over here and why it's going to return an error message that's incorrect. Let me do it again. Remember I said about the copy paste happens all the time with code. These things have been copied incorrectly. Let me type them incorrect. Whoops, sorry about that. I think I made another mistake there. What's going on there? Oh, I know what they're doing. There you go. Sorry about that. Let me do my green in, retype it. Remember, copy paste doesn't always work perfectly. Let's do that. Looks like I did pretty good. Let's do the next one. I'll read through the code in a second for you. I'm hoping you guys are thinking about learning. And you learn by reading. So I want to point out the first IP1 is an implicit plot. It's y equals a square root function. It was in red color. IP2 is an implicit plot. It looks like a straight line. It's dashed and it's green. And IP3 is an implicit plot where it's a square root function. And we got the no color given there. Let's give it a color. Let's see what happens. Let's take a look. We got red, green. Let's do color blue. And you can play around with software. That's what's great about it. Your machine's not going to blow up. Remember, shift return. Now, of course, what happens over here when I do this over here, and let me go back, and I do my copy paste, it's actually going to plot all three functions on the same exact axes. All right. Now, granted, this will look familiar to you if you've been following along in lectures. We've actually done this one. I'm going to use slightly different software. I want to repeat this to you. You are under no obligation to use software that I tell you should use. But what I want to do is just go back over the notes, and I want to find that graph. Right? I want to find it right over here, right? So someone says, where is that graph? It's this one over here. So what I want to do is I'm going to just type that one in. And what's going to be y equals the square root of x cubed plus 1. Now, I want to be honest with you. If I want to do its inverse, I can do it quite simply. New equation by just simply not typing y equals, but x equals the square root. And what are we doing? Interchanging x and y's. So it's going to be y cubed. And you should note right away how much easier this is to use. And I see it. I'm going to put one other graph in, new equation, and it's going to be the line y equals x, just like we did before, by the way. All right. Let me just, talk about pulling this guy around a little bit. And I'm going to pull it down here, get a better picture. I'm going to change this line to a dashed line. I'm going to use the inspector to do that. I got this. And I'm going to change this guy to, I don't know, we'll change to a different color, okay? And let's do a color, let's do blue. And you make your decisions. All right, let's do the other guy. And I'm going to change that to red. All right, we got a picture. Whoops, sorry about that. So some people say, I don't like your grid there. This can also be changed. Let me just go through that with you. Again, we're not teaching software. We're just showing you how easy software can be used when you master it, right? And some people are not interested. We're not telling you have to be interested. You got to find some interest that you can deal with though, all right? So I just changed that. And again, looking around over here, get a much better looking picture. Certainly as good as Sage, but mileage may vary depending what you want to use. All right. That pretty much covers that section out. I'm hoping you're now able, and you've studied the material well enough where when you go to WebAssign, it should really be a no-brainer for you. Thank you.